Hi guys, it's Mrs. Bracy and this is your lesson on the quadratic formula. I am on page 22 in your packet and the quadratic formula is written here for you in the little bubble, and we talked about this in class a little bit, so it should look familiar. And I'm going to start by showing you a little video of a song that can help you remember the quadratic formula. However, you do not have to memorize the quadratic formula. It will always be given to you. But I just kind of like this song and I thought it would be fun to watch. So I'm just going to open up YouTube here and get a full screen. Take a look. Okay, so as you can see, there's a little Pop Goes the Weasel type of song that you can sing along here, so we can do that in class if we want to later. But let's take a look at page 22 and do a couple of examples. And so the notes are written here for you. We're going to find, once the equation is in standard form, we're going to find the values of A, B, and C, substitute the values into the formula, evaluate the quantity under the radical, and then simplify the rest of the problem. Okay, so first, let's take a look at our quadratic. Is it in standard form? And yes, it is. Your standard form is written right here, and we've talked about this several times throughout the unit. So we're going to figure out the values of A, B, and C. A is the number in front of x squared. For our quadratic here, the number in front of x squared is 1. So I'm going to say A equals 1. B is the number in front of x. So for our quadratic here, the number in front of x is 6. So B is 6. And the C value is the constant at the end. So in this case, our C value is 8. Make sure you watch out. If any of these had minus signs, these values would be negative. All right, let's copy down the formula. So x equals, I like to make my big fraction first. And then we've got negative B plus or minus the square root of b squared minus 4ac, and that whole thing is over 2a. So this really is an exercise in substituting to begin with, just taking these three numbers and filling them in. This is something I really could have asked you to do at the beginning of the year, just filling in numbers. So this says negative b, and b is 6, so I'm going to say negative 6. I like to make my fraction bar, plus or minus the square root. Now, because we have a squared here, the number we fill in is going to go in parentheses. B is 6, so it's 6 squared minus, extend that out a little bit, 4 times A, which we're going to put in parentheses, which is 1, and then times C, which we're also going to put in parentheses, and C is 8. Okay, so we have 6 squared minus 4 times 1 times 8. Extend my fraction bar. And on the bottom we have 2 times A, so we're going to put 2, and then in parentheses we'll fill in the A, which is 1. Okay, once you get everything substituted in, you want to just look under the radical first. So we're going to take this part under the radical. 6 squared minus 4 times 1 times 8. You can actually type that straight into your calculator if you want to. And when you type that in, you're going to get 4. Okay, 6 squared is 36. 4 times 1 times 8 is 32. 36 minus 32 is 4. So now we have negative 6 plus or minus the square root of 4. We didn't evaluate the radical, just what was under it. And let's multiply 2 times 1 so we get 2. Now you take a look at your radical and you decide what to do with it. So I'm just going to kind of do this off to the side. Radical 4. Is it a perfect square, or do I need to simplify it? In this case, it's a perfect square, so let's take the square root of 4, and we get 2. So we're going to replace that with 2. So x equals negative 6 plus or minus 2 all over 2. All right. Now, at this point in time, because there's a plus or minus, you need to split this up into your two separate roots, once with a plus sign and once with a minus sign. So x could equal negative 6 plus 2 divided by 2, or x could equal negative 6 minus 2 divided by 2. Now we can evaluate each of these separately. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. And negative 6 minus 2 is negative 8 divided by 2 is negative 4. So our roots, which go in squiggly brackets, are negative 2 and negative 4. Now, since we got whole numbers, this means we could have solved this by factoring and would have gotten the same answers. If you can picture doing trinomial factoring and then a t-chart, that would have taken a lot less steps than this. So for now, we're just practicing the quadratic formula, but I do want you to start thinking about which method is going to be easiest and quickest for any given example. Okay, now let's go to page 23. So go ahead and flip it over. We're going to take a look at example 1. Now, here's a situation where you might not want to factor this, because if you look at it close enough, you're going to see that this is a tricky trinomial. If I asked you to factor it, I hope that you could. But if you decide that the quadratic formula is a better choice here, you can do that. Okay? There will be situations where factoring is just not possible at all. And then you can use the quadratic formula. In this case, we're just going to practice the quadratic formula. Again, this could be factored, but we're not going to do that now. We're going to do the quadratic formula. So we need the values of a, b, and c. Okay, remember this is your standard form. So a is in front of x squared, so a is 4. B is in front of x, so b is 12. And c is the constant, so c is 5. Okay, now I write down my formula. Okay, so I might have done that more quickly than you. If you need to pause it, go ahead and do that. And we're going to fill in our values. Okay, so b is 12, and this says negative b. So I'm going to put negative 12 plus or minus. Now I'd like to make my big fraction bar here. Big square root. You're going to fill in b in parentheses, so 12 squared, that's the value of b, minus 4, that's always a 4, and then you've got a, which in this case is 4, times c, which in this case is 5. And that all goes over 2 times a, which in this case is 4. Okay, so then we're going to go ahead and leave most of this alone. We're going to figure out what number goes under the square root. I probably made that fraction bar longer than I needed to. We can multiply 2 times 4 on the bottom and put an 8. So to get the number that goes under the square root, again, you can just type it in your calculator. And it's going to turn out to be 64. I did this ahead of time so that we wouldn't have to do that, since I know a lot of you don't have calculators right where you are. Okay, so 12 squared minus 4 times 5, which we can use our calculator for, gives us 64. Now we have to decide what to do with radical 64. Is that a perfect square, or does it need to be simplified? It is a perfect square, and it's equal to 8. So we're going to replace the radical 64 with 8. So x equals negative 12 plus or minus, now we took the square root of 64, so it's 8 without a radical, all over 8. Now it's very tempting to try to divide right now or do something like that, but because of this plus or minus, we really need to split it up. So x is equal to negative 12 plus 8 divided by 8, and we'll figure out what that is in a second, or x is equal to negative 12 minus 8 divided by 8. And we just have to figure out what each of those are. So negative 12 plus 8 divided by 8. So negative 12 plus 8 is negative 4 divided by 8. And hopefully you know that reduces to negative 1/2. And the good news here again is that your calculator would do that reduction for you if you just typed it in. We'll practice that in class when you have a calculator. Negative 12 minus 8 is negative 20. So we have negative 20 over 8. And mixed numbers are a little bit tough here, so we really want to just go with the improper fraction of negative 5/2. So 4 goes in, negative 5/2, okay? So our answers here, ran out of room, I'll stick them in up here real quick, are negative 1/2 and negative 5/2. Okay, and those are the answers to the quadratic. So that also would have been factorable, but results in fractions for answers. Okay. So what I would like you to do is I would like you to try number 3 and to bring that to class with you and show me how you did. A little hint here, the first thing you have to do is get it equal to 0 before you start trying to find the values of a, b, and c. So get it equal to 0, figure out a, b, and c, and then start substituting into the quadratic formula and see how far you can get on your own. Okay, so a little task to try on your own. And I hope this was helpful. I will see you in class.